Before beginning the next lesson, try the warm-up. Write in logarithmic form. So here I have exponential form. Write it in logarithmic form. And here, write as a single logarithm. So this is expanded form. We need to simplify it down into a single logarithm. So this is some review from previous lessons. Let's see if you can do it. Pause the video, try it, and then come back to see how you did. For this first one, the base is 3, so log base 3. Log base 3 of 27 is equal to x. Now, I wrote x equals log base 3 of 27. If you wrote log base 3 of 27 equals x, that's the same thing. Okay, as single logarithm here, they all have the same base in each logarithm. So we just have to look, are we adding or subtracting? That tells us whether we're multiplying or dividing in here, in the argument. So a cubed subtract b to the 4. So b to the 4 is being divided. It's being divided by that, rather. So it's on the bottom of the fraction. We're adding this one, so c to the 5 is in the numerator, because we're multiplying by it. And we're subtracting this one, so d squared is in the denominator, because we're dividing by it. So you should end up with log base 3 of this whole fraction, a cubed c to the 5 divided by b to the 4 d squared. So hopefully you could remember how to do that stuff, because you're going to need to know how to do it when we start to solve logarithmic equations. So just like any equation that you're solving, we're gonna do similar things here, except all our equations are going to involve logarithms in some way. So our goal for this lesson is for you to be able to use the properties of logarithms to solve for an unknown, so solve for x or whatever, when found in either an exponential or logarithmic equation. So we're going to be able to solve exponential or logarithmic equations using the properties of logarithms. So I really just have a few examples I want to show you, and then you can just practice this stuff. So here's the first one. Solve. So anytime you see solve, it means figure out the value of the variable. Okay, that's the unknown. Now I added this, round answers to 4 decimal places if necessary. So once we use the calculator, if your screen is filled with digits, we're going to round so that there's only 4 digits after the decimal. That's typically what I like to do for nice communication. Okay, so let's take a look at this. 3 to the exponent x equals 19. The easiest way to solve this is to take the log of both sides. So we'll have log of 3 to the x equals log of 19. Now I still have the x in the exponent, so I need to do something with that. Well, do you remember we had a rule about that? If we have an exponent inside the argument of the logarithm, we can take that and move it out to be the coefficient. So I actually end up with x multiplied by the log of 3 equals log of 19. Now remember, the ultimate goal is to solve for x, so I need to isolate x. Well, x is being multiplied by log of 3, so in order to get x by itself, I need to divide by log of 3. And if I do it to the left, I have to do the same thing to the right because they're equal. So now I'm left with x equals log of 19 over log of 3. And I can do this in my calculator. I just have to find out what log of 19 is and divide it by log of 3. So when you punch that into your calculator, you should end up with approximately 2.6801. So notice I rounded this to 4 decimal places. And just a note about communication, as soon as you round an answer, you're going to put a dot above the equal sign to tell us that it's not exactly equal to that, it's approximately this. Okay, so the steps again. If you have exponential form and you want to solve for the exponent, take the log of both sides. Use that exponent rule of logarithms where you move the exponent out to be the coefficient, and then you can divide both sides by the logarithm attached to the x. Okay, and then you'll end up with your answer. So let's try a slightly more difficult one. In this example, we're doing the same thing. We're solving the unknown is in the exponent. The real difference here is that there's more in the exponent. The exponent isn't just x, it's x plus 2. But we're going to follow the same process. We're going to take the log of both sides. We're going to use that rule for moving the exponent into the coefficient. We're going to divide both sides by log of 7. And this is where it's a little bit different. Now we have x plus 2 equals log of 55 divided by log of 7. So we need to get that x by itself. Well, in order to do that, we need to subtract 2 from the left. And because the two sides are equal, we have to do the same thing on the right. So x is actually log of 55 divided by log of 7 minus 2. So you'll plug that into your calculator and get your answer. So if you did not get this as your final answer, you should just double check that you're using your calculator correctly. It should do order of operations for you automatically, but perhaps you're having trouble. Sometimes if you do log 55 divided by log 7, then hit equals and then subtract 2, that usually fixes the problem. But if you're running into issues, let me know so I can help. Okay, in this example, we have log base 2 for 3 different terms in the equation. Now notice this. This term has an x. This term also has an x. So it's important that we collect our like terms, as it were. Let's move all the terms that have an x to one side and all the terms that don't have an x to the other side of the equal sign. So what I'm going to do is I'm going to move all the terms that have an x onto the right-hand side, and all the terms that don't have an x, I'm going to move to the left-hand side. And remember, when you cross the equal sign, you're going to do the opposite operation. So adding turns into subtracting, subtracting turns into adding. So this term here, log base 2 of x, you don't see it, but there's a plus sign in front. So when we move it over, we're going to be subtracting. And this term here has a minus sign in front. So the opposite, when we cross to the opposite side, it's going to be the opposite operation. It's going to be plus. Okay, so we'll end up with this. Notice this term on the left, now it's positive. And this term, cross the equal sign, now it's negative. Okay, so we've put all our terms that have the x on one side, all the terms that don't have an x on the other side. Now what do we do? Well, let's take a look here. Log base 2 for both. Here we're subtracting these, so I know I have that rule. I can simplify this down to a single logarithm. If I'm subtracting the two logarithms, that means I'll divide by x in the argument. So we end up with this. Log base 2 of 5 equals log base 2 of x plus 3 divided by x. Notice this. Log base 2 on the left, log base 2 on the right. If it's the same logarithm, because they're equal to each other, then that means the arguments must be the same. So I can just say, well, 5 is equal to x plus 3 over x. Now this looks a lot simpler to solve. I have 5 equals a fraction. We don't like fractions, so we got to, well, get rid of the fraction. Remember, when we're doing algebra, we're thinking about opposite operations. So if we want to eliminate the fraction, the easiest way is to just multiply by whatever the denominator is. So in this case, the denominator is x. I'm going to multiply both sides by x. Now I have 5x equals x plus 3. This is just a linear equation. We can group our like terms, simplify, and solve. So just to recap, if you have logarithms already in your equation, just group the logarithms that have the unknown in them, simplify them down to a single logarithm, and then you should come to a point where you have the same logarithm on both sides of the equal sign. So then you can just say the arguments are equal to each other, and then you just kind of use your grade 9 and 10 algebra skills to solve. This last example is very similar in that we have logarithms with the same base. They both have the unknown in them, so we're going to simplify this down to a single logarithm. Because we're subtracting this logarithm, that means I'm dividing by the x minus 3 in here. Okay, so I have log base 6 of x plus 5 over x minus 3 equals 2. So I don't have a log with the same base on both sides. So I can't just say x plus 5 over x minus 3 equals 2. That would be incorrect. Somehow I need to turn this 2 into log base 6 of something. I'm going to remind you of this rule that I showed you in the previous lesson. Log base a of a to the x equals x. I proved this in the previous lesson. This is a property that is always the case. So if I have the number 2, I can rewrite it as a log base whatever like this. So if I want it log base 6, then I'll have 6 to the exponent 2 in the brackets. So I'm just simplifying. 2 is equal to log base 6 of 6 to the exponent 2 using this rule. Okay, so now I can proceed. I have log base 6 of this equals log base 6 of this. Therefore, this is equal to this. Now I hope you'll realize what I did there. 6 squared is 6 times 6, which is 36. So I just went ahead and wrote 36 just to save some space here. Okay, so I have x plus 5 over x minus 3 equals 36. This is more manageable now. So now I can proceed like I did in the previous example. I have a number equal to a fraction. So I want to eliminate the fraction. So the way I do that is I multiply both sides by the denominator, whatever the denominator is. So if I'm dividing by x minus 3 and multiplying by x minus 3, they cancel out. So I'm left with x plus 5 equals 36 times x minus 3. So now I'm just going to expand the brackets, group my like terms, simplify, and solve. Now I've left this as the fraction. You could go ahead and put that in your calculator, just round it to 4 decimal places. Okay, so just to recap, if you are solving equations in the exponential form, take the log of both sides to turn it into logarithmic form, and then you can get it to a point where you have the same base for each log on both sides, and then say that the arguments are the same. And you can do the same thing when you already have the logarithms, as in this case. You might have to do some manipulating so that you end up with a log with the same base on both sides, but then the arguments are equal, and then you just use your grade 9 and 10 algebra skills to solve. Okay, so hopefully that gave you a little taste of what you can do to solve these logarithmic equations. Now it's time to practice. So as you're working on the practice questions, if you run into any difficulties at all, reach out and I'll do my best to help.